Factoring Day 2, we're going to look at some shortcuts that you can use to help you solve factoring problems. Difference of squares states a squared minus b squared becomes a minus b times a plus b. Use this through each one of these examples below. First and foremost, you're looking at a squared term, x squared, that's a squared. Subtraction symbol followed by another squared term, which is 5 squared. So the difference of squares says x squared minus 5 squared becomes x minus 5 times x plus 5. Without the shortcut, you simply rewrite it as x squared minus 0x plus 0x minus 25. Split the middle term, or a times c, 25, split the middle term, x squared minus 5x plus 5x equals minus 25. Four-term grouping, factor out x and you get x minus 5. Four-term grouping, you factor out the 5 and you get x minus 5 for the 5. So you can see how the actual factoring backs up the shortcut. Use the shortcut, recognize when to use it appropriately. 169, 13 squared minus x squared, so that becomes 13 minus x times 13 plus x. Now this one incorporates a little bit of a different idea. What I'm going to do is I'm going to rewrite this as 2 squared y squared. Then I'll rewrite this as 2y quantity squared minus 7 squared. So there is your a term, there is your b term, and you get 2y minus 7 times 2y plus 7. Again, a little bit different look here. We're looking at a greatest common factor, so you always want to approach it with the GCF removed. So it's going to be 3 times x squared minus 9, and there's your perfect squares. 3 times x minus 3 times x plus 3. Not everything is the difference of two squares, so don't try to make everything the difference of two squares. Notice 20 and 36 have a GCF of 4, and so you get 4 times 5b squared plus 6, and there is plus 9, plus 9. And then you'll notice again there is no difference here, there is no perfect square, so that is as factored as it can be. Okay, looking at this from a different point of view, that is x squared squared. And remember, 1 is the smallest perfect square, which is 1 squared. So now you get x squared minus 1 times x squared plus 1. Again, you're looking at it from a different point of view, so we are going to actually use the difference of two squares twice this time. Notice that x squared minus 1 is the difference of squares. X squared minus 1 becomes x minus 1 times x plus 1. Notice that this is not the difference of squares, even though these two are perfect squares, so this is and remains x squared plus 1. Alright, in order to introduce the sum of cubes and difference of cubes, we have to first wash up, as it were. We have to use our soap. Soap is same, opposite, always positive. This refers to the sign changes for the sum and difference of cubes. The sum of difference of cubes both refer to terms or binomials that are perfect cubes. So that is going to be A plus, sorry, let's not do that. Got to incorporate SOAP. A, then B. Then the trinomial is going to be A squared, AB, B squared. Now we use SOAP. Same refers to the same symbol in the first blank. Opposite refers to the second symbol, which is the opposite of whatever it is, and in this case it's the sum. And always positive refers to the symbol that goes in the third blank. Same, opposite, always positive. The difference of cubes is the same with a minus sign between. Again, it's A and B, followed by A squared, AB and B squared. Same, opposite, always positive. Remember your SOAP and you'll never get these problems wrong. Okay, so first of all we have to acknowledge that they're perfect cubes. That's x to the third plus 4 to the third. So it's a plus sign, we become the sum of cubes. X, 4, x squared, 4x, 16, and now we incorporate SOAP. Same, opposite, always positive. Changing these into your perfect cubes, that's 3 to the third power plus 2 to the third power times x to the third power. You can rewrite that as 2x quantity to the third power. So you get 3 and 2x, 9, 3 times 2 is 6, 6x, and 4x squared. Same, opposite, always positive. Acknowledge that this is a perfect cube, change it to here, minus x to the third, 5x, 25, 5x, and x squared. Same, opposite, always positive. 343 is 7 to the third power, x to the third power minus 1 to the third power. Remember, you can change that to 7x to the third power as a quantity. So that becomes 7x, 1, 49x squared, 7x, and 1. Same, opposite, always positive. Shortcuts in factoring are going to be a very key role in helping you solve algebraic problems more simply, more quickly, and more easily. Please make sure that you commit these to memory so that you can make your job with factoring a lot more simple.